Hello, everybody. Meteorologist Hutch Johnson setting up here so we can get started with class number 1 on Monday. Their seasons is the topic for today, so we'll be getting started here very shortly. Waiting for a few of you to get on board, and for those of you who are live, that's great, and others who will be watching this, we'll keep this posted on our Facebook page so you'll have the ability to see it there. So still getting set up. I really appreciate the fact that you are here today. And if you are here, go ahead and leave a comment and tell me where you're watching from and maybe your age. So this is the first time I've done this. My name again is Hutch Johnson. I'm Chief Meteorologist here at Valley News Live. If you happen to be, Mark from Germany. Wonderful. Welcome from Germany. Talking a little bit of weather today. I am a television broadcast meteorologist here in the Fargo-Moorhead area, and with that, I got to tell you that there is, we get all kinds of weather here in the upper Midwest. Kids, you're home. You got a lot of time on your hands right now, so why not talk a little weather? My day job, Chelsea, thanks for joining me. Reed, thanks for joining me from Grand Forks. Emily, thank you. Ages 10, 9, and 7. Good to have all of you watching from Roseau. All right, everyone, thanks for chiming in. Chime in with your location and where you're from. Would love to see that. Today, we're going to talk about seasons. Now, who's Hutch Johnson? Here, let me show you me. I'm going to do my best here. We don't usually stream, so here I am in the studio. We have set up for broadcasting. This is fun. I love teaching. I love talking about weather. I do it every night. But in the 3 minutes that we have to talk about weather on TV, about the forecast, we focus on our forecast area. We don't get a lot of time for teaching, so I'm pretty jonesed about this. Secondly, for about 20 years, I have taught a meteorology class. So introduction to meteorology along with the lab to college students here in the state of North Dakota and the Bismarck area. So hey, Bismarck, if you're watching. Jace from Jamestown. Jeanette, thanks for watching, age 7. All right. Now, here's a little bit about what you're going to see with this course this week. We're going to talk about a different subject, and I know I could have picked some really exciting topics in weather. I picked this one because I think it's fun. I think it's important. And, it's a challenge as a scientist to not be overly scientific about some of these topics, but to find a way to present information that everybody can handle. So what age group is Hutch teaching to today? Let's say from 5 to 95. Okay, so it's a little bit for everybody. And some of you may have seen this content or material before, and that's okay. Dee, thanks for joining in. Teresa from Fargo. Tyler Ulrich from Lake Park, Minnesota. Love to have all of you here. Let's go ahead and get started with a little bit of the content. And I do want to point out this. If you do have a question, you can ask, and I'll try to catch some of these in the presentation itself. I'll leave time for questions and answers at the end if you have specific questions about that. If you have comments, I will try to get to all of those after the event. So if you don't hear me address your particular question right off the bat, don't worry. I'll do my very best to get to all of that information in the coming moments right after this live broadcast ends. So now I'm trying to switch my phone camera right around, and let's go ahead and get started with a little look at what we have going on for today's topic. Now, we're talking about seasons, and one thing to start out with seasons, hey, it's Hutch, I'm a teacher. I've got an apple. So you don't need to send me apples. And if you're a teacher and you like this, go ahead down in the comments below and tag somebody you think might enjoy this. So if you have students, tag them. You can do that in the comments by hitting @ and their Facebook tag. So you can get people on board. Let's talk a little bit about the sun. It drives our weather and it causes our change in seasons somewhat. But the real fact of what I want to point out today with regards to seasons is something that's real simple to point out. If you have a flashlight, Hutch has a pretty one here. It's purple, see? Now, flashlights are a pretty good way to help explain direct sunlight versus maybe indirect radiation from the sun that hits at a glancing blow. Let me tell you what I mean. If you take a flashlight and turn it on and you point it straight at something, like the camera lens here, all of the energy from this sunlight or from this flashlight is going into one focused location. Okay, so let me show you how that looks here while I ditch my chair. When we point straight at something or perpendicular to it, all of the energy from this light goes to a small area, and all of that is lit up. So this small area on this board here is getting illuminated brightly with a lot of energy from this flashlight, okay? So this is what it looks like when the sun is directly overhead. At high noon, it's coming through a shallow layer of air. The atmosphere, 50 to 100 miles deep. So that sunlight doesn't have to go through a lot of air. So it doesn't get scattered or all the things that our atmosphere or particulates that are in the atmosphere can do to that light. It just comes straight through that atmosphere with limited blockage, and it warms up the surface of the earth. Now think about what happens when you're walking with a flashlight and you're pointing it at the ground ahead of you. The headlights on your car, for instance. That's a glancing blow. So you see all of the energy from Hutch's flashlight here in the morning or at night when the sun is rising or setting is spread out over that huge area. Do you see that? So the same amount of energy is trying to light up a larger surface area. So each location on the planet gets less heat and less energy because the angle that the light is coming in from is so shallow. Okay? Now, that's part of why we heat up warmer. We have more sun. That sun is warmer at noon. The other thing to consider when the sun is low in the sky is the fact that this light originating at the sun is going to hit the Earth's atmosphere, and it might have to travel through thousands and thousands and thousands and thousands of miles of atmosphere before it gets to you. So first thing in the morning, that light that's coming up over the horizon is spread out over a long distance. You get a glancing blow, but not only that, a lot of that energy is more diffuse because the atmosphere has reflected, scattered, bounced some of that energy in different directions. So hopefully that makes sense to you about direct radiation from the sun versus this glancing blow. Now, we do not live on a flat Earth. So I want to point that out right now. Our Earth is shaped more like a sphere. So I got, well, let's see. Not a sphere, not a globe, but a basketball. Basketballs are more fun because you can bounce them and it shows up pretty cool. And it's like the Earth, it's spherical shaped. Okay, kids, I got a question for you. Students, everybody, let me see if I can pull this up. Pardon me while I try to see where I am, and I can see your questions online. I want to make sure I can see questions because I'm going to ask you a question and then you get to answer here. So hold on. There we are. Okay, so pulling up my questions here. Sorry about this. This is my rookie time doing a Facebook Live like this class here. So, all right, now I think I can see your answers. So we're going to let you answer some questions here. First and foremost, our sphere that we live on, we're stapled to the Earth, and this sphere rotates on its axis. It spins like this, okay? So if one of these basketball lines is the equator and it's spinning, can you guys answer and tell me how long it takes the Earth to spin on its axis? I know there's a little delay, so we'll go ahead and delay. I'll see what we get for answers here. Watching with your daughter from apartment June, welcome. Apple, thanks for watching. Melody as well. How long does it take the Earth to rotate on its axis? Anybody know? Okay, 1 year. Okay, Dan, that's a good guess. It takes not 1 year. Let's wait for a few more answers. How long does it take the Earth to rotate on its axis? Kaylin, thank you. 1 day. 1 day, 24 hours. The Earth rotates on its axis like this in 1 day. Now, it takes a sliver more than a day for the Earth to rotate on its axis. And that's why once every 4 years, we add an extra day to the calendar called a leap day. That happened this year. Kind of cool. So we added 1 day to the calendar to make up for that little itty bitty extra amount of time it takes each day for the Earth to rotate on its axis. 24 hours is how long it takes the Earth to rotate on its axis of rotation. Cool. For those of you that answered 1 year, you're right in the sense that that's how long it takes the Earth to travel around the sun is 1 year. So the Earth makes this path around the sun in a year's time. That's 365.25 days, but we don't count the 0.25 days. We just forget those, and then we throw an extra day in every 4 years. Make sense? All right. So our Earth is not only rotating on an axis as it travels around the sun, but it's tilted on the axis of rotation. So let me show you this, and then let me tilt the Earth a little bit. Let's say the Earth is tilted 24.5 degrees, 23.5 degrees is the tilt of the Earth on its axis as it spins on its rotation, axis of rotation. So it takes a day for it to spin around, and here's the deal. Because the Earth is tilted on its axis, the incoming sunlight here illuminates different parts of the Earth. So I have a graphic or two to help illustrate this. Let's go ahead and switch this around while I wobble switch my phone camera. Okay, now I'm here. Now let's go there. Oh, I was right the first time. All right, very good. Now let's move on and let's take a look at this. We just had the season of spring start. Sorry, my phone is wobbling. Spring started, and spring happens. It's called an equinox. And equal night. Okay, so the equal night means every point on the surface of the globe is 12 hours long daylight and 12 hours of nighttime. So it's that time of year when we get 12 hours of sunlight and 12 hours of nighttime. Now, we don't live anywhere near the equator, but on an equinox, that is when the direct rays of the sun are exactly over the equator. So as the Earth makes its trip around the sun, the direct rays from the sun that we were talking about, those direct rays hit the equator on an equinox. And then they move up and hit the Tropic of Cancer when we are in our summer months. So the direct rays of the sun amble north. And that's what makes our weather a little warmer here in the northern hemisphere when we go from spring towards summer and then through summer. In our cold season, which we're just exiting right now, the direct rays of the sun slid south of the equator. And this has a huge impact on how much daylight you get over the course of a day. So let's take a look at this one example to show you how this tilt on the Earth's axis can impact how much daylight you get. So on the autumnal equinox, the direct rays of the sun are at the equator. Everybody has 12 hours of daylight and 12 hours of darkness. But on the winter solstice, the direct rays of the sun right here on this graphic are heading in to 23.5 degrees south of the equator. So if you're in the southern hemisphere, south of the equator, the direct rays of the sun are in your hemisphere over the tropics and not over us. Do you notice how this part of the globe up here has zero sunlight? So as the Earth spins on its axis, the sun never, ever even comes out if you live north of the Arctic Circle. If you live on the South Pole, in their summer season, the sun never sets. It stays up. It stays up all the time. So a couple of cool facts about this. Here in North Dakota, where we're from, I can't answer for Germany, although look at this. We are in the northern hemisphere, and we are a long ways from the equator, and we're a long ways from the tropics. The tropics are located 23.5 degrees, the same as the tilt of the Earth, north and south of the equator. That's where the direct rays of the sun always hit, right? That's where the most energy from the sun hits. That's where it's warmer. This time of year, we love to go to the tropics and visit down there. We live between 45 and 50 degrees north of that, way up here. In the winter, our daylight hours in North Dakota, on average, drop to a minimum of about 8 hours a day. That's it. That's all the sunlight we get. The rest of the 24-hour day is dark. That's why we get so cold. We only have 8 hours of warming. And not only that, because we are so far north, the sun's light hits us from the southern sky at a really ridiculous angle, and we just get a glancing blow of sun. So even at high noon, that sun isn't right overhead, and it's not very powerful. Now, when we go into our equinox, which we just went through, okay, March is an equinox. We have the autumnal equinox in September. That means the direct rays of the sun are over the equator. That's not as direct of rays as we get, but we get 12 hours of daylight. We're warming up. That's what we have now, about 12 hours of daylight. When we get to our summer solstice, that's June, on or around the 21st of June, we will have 16 hours of daylight here in Fargo, North Dakota. That's cool, because when Hutch gets off news at night at 10 o'clock, and when I'm done with the news at 10:30, I go home, and it's still light outside. There's twilight, and I can mow my lawn. But my neighbors might not like that, so maybe I should refrain from mowing the lawn. Okay, that's it for class today. It's been a short one. The topic is not as real exciting, but we have more topics that we can go over here as we move through the coming days. Tomorrow's topic will be types of clouds and what they mean. So we'll talk a little bit about clouds on Tuesday. I want to keep these relatively short and sweet. And Shannon White, thanks for joining. I got to ask you though, if you have questions, let's do a little bit of Q&A here. So because there's a delay, I'm going to talk to you a little bit about our class tomorrow and let you know that clouds are super important to weather, because when people are telling me what they're concerned about, what they want to know with regards to the forecast, they want to know whether it's going to rain or snow. They want to know whether it's going to hail or thunderstorm, or if there's a chance of tornadoes or a blizzard. Okay, and all of those weather phenomena, rain, sleet, snow, hail, thunderstorms, tornadoes, even lightning, often comes from clouds. So clouds are real important for meteorologists to forecast and to predict. So if you do have a question, go ahead and fire that up. I'll try to look. Thanks, Sarah, for logging in from the Fergus Falls area. A lot of folks from the area. Osgood Elementary, Lily joining me. Thanks so much for joining us today. Got to tell you, it's been a lot of fun. If you like this, please go ahead and click like. If you want to share this with someone, go ahead in the comments section and tag them to share it. And we'll have another school lesson tomorrow. Again, I've done the school teaching thing for about 20 years. I have taught a meteorology class at a local state college. It is a lot of fun. Sometimes science topics are a little harder for us to understand than others, and I hope that this shed some light on the topic for you. Hopefully you're getting out. Hopefully you're enjoying your time with your family and making the best of this tough situation. That's one of the reasons why I'm really excited to do this. So, Britt has a question. Is the Earth a little let me see if I can see it. They're coming in quick. I missed your question, Britt. I'll get back to as many as I can. Let me see. How do you know how to track the Earth, Teresa? Well, that's a great question. We have NASA scientists that actually track not only the Earth's movements, but the sun and how much energy is coming from it. So there's scientists that really focus on small areas. Good question. Excited for the lesson tomorrow. That's good. Courtney, thank you. Asher, for watching. I'm trying to get back to the question. Is the Earth at a tilt because it has been hit by things such as meteoroids? Oh, in the development and whatnot of our planet, a lot of things happen to it that we see scars of on the moon. When you look at the moon, you see all those craters that are left on it. Well, the Earth took some blows too. So that could be very well one of the reasons we have the tilt that we do. Why is autumn sometimes cold and sometimes hot? Gina Zimprick, thank you for your question. Gina, seasons are the toughest ones to forecast are those transition seasons that we're in right now. So autumn is a tough one because we can get really cold air. And in the spring, we can be either really cold, like we were a few days ago with our snow moving through the northern part of our viewing area, to quite warm. And I want you to think of this too. Areas out west in western North Dakota, if you're watching from anywhere west of Jamestown, hi, thanks for watching. Love to see what it looks like out there because you have bare earth, okay? And bare earth makes a huge difference in how warm you can get. So when we look at a satellite image, and let me pull one up. I've got my fancy pants computer here, so let me see if I can pull up a satellite image. And we'll go to a visible satellite image, and I want to show you that there are places that we can see from space that have no snow on the ground. So this is one of the ways we monitor the Earth and we monitor where the rain, sleet, snow, hail is. But let me go ahead and pull up a visible satellite image and you'll be able to see, boom, there's clouds moving on this image, but there's areas where you don't see snow on the ground. So the white that you see on this image, some of it's clouds moving. Right here, clouds moving. Up here, the white isn't moving by Langdon and Walhalla, and you know what that is? That's snowpack on the ground that's still there, so we can see it from space, okay? Now, when we look out west, Bismarck, the ground looks pretty bare. Very little to no snow left. Your temperatures out in the western part of the state are reaping the rewards of having no snow. Because once that happens, look at what our temperatures can do. Look at the difference in temperatures right now Here's now. 51 in Bismarck, no snow on the ground. 34 at Fargo, we have clouds and definitely still snow on the ground. Okay? This has everything to do with what we just learned about in class today. Sunlight coming in from the sun hits snowbanks, it melts the snow, it warms the snowpack, it reflects a lot of energy back to space. That's why these snow piles look so bright white here and up by Langdon. Okay? Where we have dark earth, that absorbs the sun's energy, allowing it to warm the air and atmosphere. All of this is a lot of fun. All of this is why Hutch really got into meteorology when I was a youngster. I was in Billings, Montana. I grew up 4th grade, and I got to tell you, when we had a stormy day make its way into the region, we had a tornado warning, and I went outside to look at the clouds. I don't recommend that. I tell folks, please don't do that. But that's what Hutch did, and I've been hooked on weather ever since. So, Tyler Ulrich asks, what causes the wind? That is the topic for one of our day's classes this week. So I don't want to get too far ahead of myself. Look at this, Wednesday, wind, and what makes it blow. So we'll get over that. You guys are the best. Again, if you have a question, comment and leave it in the space below. I'll get to as many as I possibly can. Invite your friends by sharing with them in the comment section. Go ahead and tag them. Tag them in the comment section. They'll be able to see this video too. You can send a link to it as well. And by all means, let me know if you have ideas for topics other than the 5 you see on your screen here. Special thanks to our sponsors at Luther Family Ford for making this happen. They also sponsor our Weather Kid program. They're great in our community. And if you've never seen the Weather Kid program here on Valley News Live, it is a beautiful thing. Once a week, we have a kid come in and they help me do the entire weathercast. It's not just one graphic or one special kid thing. It's not pre-taped, it's live. And you kids amaze me at how well you do. So if you liked what you saw here today, go ahead and hit a button. I really like the big smiley face one, the laughing one. That's one of my favorite ones. Or the wow. Okay? So give me a like, give me ideas, post questions. We'll get to those as we go through the day. And, be healthy, stay well, eat apples, and take care of each other. And we will see you same time, same place tomorrow. And don't forget to tune in for Valley News Live tonight, of course. We'll see you there. Thanks for watching, everyone. See you, Victoria. See you, Barbara. Thanks so much. We're going to wrap it up. Thank you. The river is going to flood, Doug Johnson. Yeah. The river is heading towards flood stage in Fargo. It will hit flood stage. It's going to happen within the day, a 24-hour period or so. We'll be on our way to 18 feet. Now, will we hit over 30 feet? Highly likely. So it's going to be a spring event, but I think it's going to be most impactful north of Fargo. We'll keep you up to date on that on Valley News Live, of course. Thanks for your questions and your comments and your likes. Y'all are the best.